Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, no more problems because we're going to continue our discussion of meteorology today. Air Temperature Simplified. This is about data, a little mathematical stuff here, right? So we want to just define a bunch of different terms, right? And when we talk about weather, there's a bunch of things when we talk about the temperature. So let's just list them. So what's the daily mean? Now, mean is a statistical term, right? It means average, right? So this is the average of the high and the low for a day. So let's say today's high is 90 degrees and its low was 60 degrees. 90 plus 60 divided by 2. Simple. That's the daily mean. Now, the daily range is the difference. Difference is a mathematical term, means subtraction. The difference between the high and the low. So again, in the case I just used, it was 60 degrees, 90 degrees. The difference is 30. The daily range is 30 degrees. The next one is the monthly mean. This is the average of the dailies. So we take the daily mean today, whatever, let's say it's 74, and then you take tomorrow it's 84, and the next day it's 72, and you add them all up over a month, and then you divide by 30 or whatever the number of days in that month. The annual mean is the annual is the average of the monthly means. You take, January, February, March, April, whatever. You find the mean, the monthly mean. You average them together. So what this does is it gives you a picture. All these things gives you a picture of what it'd be like to live there, right? The annual temperature range, this is the difference, all right? The difference, again, subtract, between the highest and lowest month. So let's say in Houston, the highest month, I bet the average high, well, that's be the mean. Let's say the average high is 80, maybe in July. I mean, it might get to 100, so let's say 85 or something like that. And then, this is in Fahrenheit, sorry, Celsius people. And then in the middle of January, or the month of January, maybe that's our coldest month, I don't know. Let's say that our average is 60, so our variation would be, the temperature range might be 20 degrees or something like that. Some places, though, you'll find very different, with the high and the low are very, very significant. So I used to live in Colorado. When I lived in Colorado, the summers could get quite warm and hot, 90 degrees and stuff like that. But that's the high temperature. But it'd get down to like just 20 or 30 degrees or 0. I don't know. It'd be very, very cold in the winter. So it would have a much, much bigger annual temperature range. So much more of this kind of a thing. An isotherm is something that's done on a graph. So it is a line. We're going to do something with this in a minute. It's a line that connects equal temperatures on a map. I'm going to show you how to make one of these and what they look like here in just a minute. And the temperature gradient, this is an important one that's related to this map. It is the change per unit distance. Actually, let's take a look. Here is a isotherm graph. And if you look at this, those lines, you see the lines, they represent areas of the same temperature. They're not perfect lines in graphs. And you'll notice kind of near Colorado where the lines are closer together, that's where you're going to have a higher temperature gradient. It kind of looks, if you recall, like a topographical map, but now we're talking about temperatures. And then you're going to have a big change in temperature there in Colorado because the lines are super close together. Probably there that's caused by the altitude and stuff. It gets higher up in elevation, and we've learned about that. But so different land, and so this is called an isotherm. Speaking of isotherms, I'm going to show you how to make an isotherm map given some weather data. All right, the key when you're drawing an isotherm map is to find places of the same temperature. So here we have 20, 20, 20, 20. You're going to draw like a circle. And if I see the 20, I'm going to start with the lowest number, like 20 degrees. I'm going to connect the dots, or if you will, I see 20. So we've got a band of cold temperatures. I'm going to sort of leave this, I think it's going to be more of a circle because I see a 30 here. I'm trying to find ultimately kind of circles. And up here in Canada, I see 30, 30. You kind of see in the patterns. This is going to be like where the temperature dips big time into the south. 25 is going to be right in there between. It's going to be like this. So this band inside of here would be less than 20 degrees, 20 to 30 degrees. Now let's see if we can find the 40 degrees. I see one here and here. This is actually where we see a big dip of the jet stream. And it comes to here, here, there. Now let's see 50. I see a 50 here. I just see a 50 here, don't I? That kind of dissipates, because then we've got 60 here, 60 here, 50 here. But if this is 60, so let's think about this. If this is 50 and this is 40, it doesn't actually say 50 there, but we can kind of make an assumption that the 50 is kind of going like that. Here's my 60. They're all close together right here. If that's 80 down here near Houston, like where we are, and the 70s are probably going to be a similar tight thing through here, because it's going to right before Houston, and there's 80 there, and then we've got our 80 here, and then 90 here. So you're going to draw isotherm maps that look like this, and basically, yeah, this is our 20s or less. Actually, these are your 10s, if you will, between 10 and 20, and this would be your 20 to 30, 30 to 40, and sometimes we'd say these are the 20s, these are the 10s, these are the 30s, the 40s, the 50s, the 60s, the I did that wrong. 40s, 50s, 60s, 40s, 50s, 30 to 40, 40 to 50, 50 to 60, 60s to 70s. Oh, I see. Here's what I did wrong. This, yeah, and then these are the 80s here, 80s here, and 90s here. I did something wrong. 70s in this ballpark. Didn't draw that very well, but I think you get the idea. That's how you draw an isotherm. All right, and that's what I want you to do, is we're going to do an activity now in class where you're going to show yourself, you're going to learn how to make an isotherm graph, answer some questions about temperature gradient. These things are key to understand how to calculate these, and we'll do an activity related to you doing some math. Simple math, it's just averages in class. We'll see you in class, speaking of which, because Houston, we don't have a problem.